It is finally time for our opening keynote. Our next keynote speaker is one of the most accomplished voices in AI and autonomous systems, a pioneer whose work bridges science, innovation, and humanity. With over 2 decades of shaping technology at NVIDIA, Ford, Intel, and even the White House, she holds 18 patents, more than 50 publications, and multiple global awards, including recognition as one of the most powerful women in tech. Please welcome Dr. Justyna Zander, here to show us how physical AI is transforming not just machines, but the way technology connects with human emotion, resilience, and purpose. Dr. Justyna Zander.
Hey, guys. Hello, welcome, good morning. I hope you enjoyed the party last night. I have that privilege that somehow I speak after the party, which means I already know the audience, except I don't know the audience that is listening online. But hello to everybody, and I hope everybody in the world has a lot of parties, because that matters too. Thank you for the introduction, Lisette. The topic today is physical AI. I'm going to be talking about my past 2 decades at work, which is autonomous driving. But I will also touch upon the robotics, because this is the era of robotics that we are now entering. And all this in the context of emotional intelligence. And I will tell you why in a moment. But first, for you not to be lost in the entire talk, the agenda is going to be, first I'm going to tell you why we even touch upon this topic. I will explain what physical AI is with AI attached to that. And then I will tell you what is the architecture of a system for a physical AI for today and for the days on. We will talk about a few case studies and cost and impact of physical AI, the way I foresee it. And it's going to be a little bit speculative, so we will see how you receive it. You will always have this agenda at the bottom so that you don't feel lost. I tend to jump from topic to topic sometimes when I talk, so feel free to look at the agenda if you are lost. So the reason I even started thinking about physical AI with EI in it was because when we had this ChatGPT moment in November 2022, the first thought that I had was that, wait a minute, so intelligence is democratized to the extent that now it does not really matter how well you're thinking. It matters more what questions you are asking. What is the agency that you are after? And so I started looking into the governments of the world, and at the White House, I noticed that they had this initiative, presidential initiative, on cyber-physical resilience. That was the only one I could find that related to physics, in the sense of physical world. So not physics as a field, but physics in the sense of robotics. The term cyber-physical comes from the past. They didn't upgrade to physical AI yet. I think today everybody is clear that we renamed cyber-physical into physical AI. And the way they came up with the call for the industry to look at was in terms of resilience. What is resilience? Resilience, in the easiest way to explain, is basically come back from every setback, jump up from a failure, and make sure that this failure is not impacting the society in a negative way. And the reason they came up with this problem statement was because the way we build our systems today is basically incrementally. So we do a lot of patchwork when things fail. For example, infrastructure fails, or energy grid fails, or I don't know, we had pandemics, so there were many things that were going right and many things were not going right. So this type of resilience. But notice that it is a very defensible way of thinking about the future. And what we really want is an actionable future. It's not about resilience and thinking about the failure. It's more about what does it teach me, and how do I make a jump to actually take action and create something positive in the world. That's how it started in 2023. 2025, what you're actually seeing a lot of action, especially in the United States. You see the manufacture of AI data centers, all accelerated computing. Even in Norway, this one is from Norway, 230 megawatts capacity, I think in Narvik, somewhere there. So I found it interesting. And so if you have this mindset of action in your head, then I asked Grok, imagine to produce a future for me. And here are three different Grok Imagine videos that take you 1 second to create. One is the very smart manufacturing, basically AI-driven manufacturing, where all the robots collaborate with each other and produce goods for us, basically as a sign of abundance. Another one is this cute little California town where I live, which is enhanced with self-driving vehicles and delivery robots, and there is quite a few humans on the road because they basically can walk everywhere because the traffic congestion is so much less, because now everything is autonomous. So that's the future we are envisioning, and the final one is seamless delivery and super fast delivery with surveillance. Now, if we take it as first principles that this is the future that we want, then what does it mean for us as humans? Well, it means we would kind of need some kind of like an orchestration platform that works like an LLM, except for the physical world. So it has this intelligence to tell the robots what to do and how to fulfill various tasks for us, instead of us putting the labor into it. And what it does to us as humans, it gives us this new time, basically new time window, where we don't have to worry about the labor, and now we can leverage it for doing whatever we want to do. Party is one thing, but maybe not necessarily party. More like having an agency to create something new, something that is going to fulfill our desires, our needs, or maybe just our hobbies, whatever it is going to be. So frankly, what we as humans can aspire to is the abundance of goods and services, but preserving the human agency and being in charge of all the robots, of the intelligence and the physical intelligence that we are creating, or that is actually really being created as we speak, because the technology pace does not stop, whether we want or not, like we heard from Simon yesterday. Now, let's go for a moment to emotional intelligence. You know Jeff Hinton because he just won the Nobel Prize last year. And this is mostly because of his contribution to AI. And what he tells us, basically right before or after winning the Nobel Prize, he left Google because he said, I helped to create a technology that I don't quite understand where it's going, and I'm afraid of the risk that it is providing to us as humans. And for some time he was in this pessimistic mindset, but now he actually switched. So in that last interview in the summer, he was just saying that actually I found out that AI is going to augment humans. And if we take it as a first principle that AI is augmenting us and not replacing us, then we can build AI such that it's going to have some kind of like maternal instincts for us as humans. I personally think maternal instincts is a little bit too much, but let's call it emotional intelligence. Let's design the AI systems of the future with EI in it. It's that simple. So if it is that simple, then what is emotional intelligence? I looked into the definition and I checked it with my friend who is a psychology researcher and globally renowned. And she told me, yeah, these are those 5 components, really. Self-awareness, so understanding things around you, the situation where you are in. Self-regulation, so responding to the situation. motivation and intent, which really translate to the human agency. What do we want to do and why we want to do it? And then also empathy and social skills. So the way I interact with you and the way you talk to me and how we feel about each other. So if this is the case, then we want to put system resilience from the initial White House call into it. But we also want to preserve the human agency, like I'm saying, which is really embedded in the motivation and intent box. And you, as an engineer, are going to understand where I'm heading now, because physical AI system boundary could be seen as a boundary that includes all those components of AI. And I tried to match those you know, the psychology concepts into the technical concepts that I know from my work on autonomous machines. So the self-awareness is basically the perception network, the neural networks that are able to basically walk and see around and recognize all the objects that you are in. So if I'm a robot, I recognize there are two laptops here, there is some bottle of water and a glass. That's self-awareness of a machine. And then self-regulation is the machine is not going to walk straight into those laptops. Instead, the machine is going to know how to regulate and basically control the policy and walk around it. So that's the second component. And then the third component is really interesting, and I'm going to explain it in a little bit on the next slides, because it's the end-to-end neural network policy. Basically, the neural network that understands the motivation of a human while performing a technical task for the human. It's a little bit difficult to get. So let's do the reality check based on autonomous vehicles. You are in Scandinavia here, you are all electric. I'm hearing in Norway, 98% of the vehicles are all electric. I picked Tesla Roadster because that's my favorite one. Everybody can pick whatever they want to pick. Now, how is it that Tesla already drives itself? And I want to reassure you, it does drive itself in California. Of course, in the sunny, beautiful weather, a little bit of rain, but not too much. It does drive itself. I have the hardware 4, so the newest hardware from Tesla on my vehicle now. And I tell you, 99% of the time, it just does the job. Sometimes I take over, for example, on the windy road on the hill. In Californian hills, it's a little bit dangerous because they're extremely narrow. I don't know how you guys, but I have a fear of height. So I'm really afraid driving there even when I manipulate the car. So I want to show you that video. It's a video from X, so Twitter, that one of the fanboys of Tesla recorded. And look, this is in San Francisco. They're going up the hill, and they're trying to make a turn left. And of course, there is a lot of traffic and humans going on. So on X, they're laughing a little bit that they're being bullied by other traffic members while they're trying to make a left turn. So I don't think they are bullied. I think they are just not being ignored. So see, like everybody is going, and at some point the vehicle turns. Not yet. One more going, and then it turns. Why does it matter? Well, it matters because in those Californian hills, when you go up, and like me, you're afraid of high, I'm really scared. I'm just like sitting there, and I don't know if I'm going to make it even straight because I'm so scared of that hill. And you saw that the hill was going down, right, straight. So then it's turning, and it does it all by itself with a little bit hesitation, most likely because of that hill and the steepness of the hill. But it does the job, and it does the job in the city. So that's one that is interesting. Then you have another one, the company called Wave. It's a startup from UK that now went to Canada and the US. And I want to show you that video for a reason. So here in the video, you have the NVIDIA CEO, Jensen Huang, the one and only, and Alex Kendall is the CEO of Wave. And the reason they met, this was probably this summer in UK, was because Jensen was giving Alex the newest inference chip that goes on the vehicle. It's called NVIDIA Drive Thor, Thor. It's about 1,000 trillion operations per second. Why does this matter? Well, it matters because the more compute you have on the vehicle, the better the vehicle is going to be able to reason about how to drive and what your next maneuver is going to be. They did this drive in UK, in London, so they're on the other side of the road, as you can see. And they were going through the roundabout, which seemed like a very good, smooth experience. We're not going to watch the whole thing. Now I'm going to start building up the architecture of physical AI system. So we are now in this autonomous vehicle boundary for a moment so that you don't feel lost. And then we swap into physical AI. So what I told you so far is the compute. The 1,000 trillion operation per second compute. Sometimes you actually have two GPUs in that vehicle, so you would total have 2,000 trillion operation per second. For humanoids, it's even more. From the estimate from Elon Musk or Figure AI company, they're saying it's going to be most likely more like 4 chips. So 4,000 trillion operation per second. And of course, every architecture is improving. So 4,000 as of today, as of tomorrow, it may double, triple, or whatever it's going to be. So how is it that this autonomous vehicle actually works? How does the autonomy work? There are many, many ways of building autonomy. People have been doing this for multiple decades. We have Waymo that is deployed in San Francisco, and it actually works as a robotaxi service. You can go and grab it, and it just works. Same in LA. Tesla started with the robotaxi service in Austin, Texas. From what we are hearing, it works as well. But we don't have as many statistics as we have about Waymo because they've been on the market only since June. So we don't know that much. But I still want to go into the direction that Tesla implemented on the vehicle because it's generative AI. They basically swapped 300,000 lines of code of the past, and they replaced it with one end-to-end neural network in 2023. So in a sense, you could feel like they did it all over. Well, of course they didn't, because they already had the entire tool set and the pipelines, and you are the developer, so you know more than I do how those pipelines work and how to maintain them. They had the data collection pipeline. They've been collecting the data for at least a decade, many data, petabytes of data per day, per hour actually, because they have about 8 million vehicles on the road globally. The way it works is you have 8 cameras, it's all vision-based. It goes, so basically those cameras are streaming into the neural network, and neural network is responsible to output the next maneuver for the self-driving vehicle. And that next maneuver, okay, that's too fast. The next maneuver is basically 2 signals, really: acceleration and steering wheel. That's all. You have 3 here because braking is also included. Why does that matter? Well, basically it matters because that end-to-end network now does all the job. Everything inside of the neural network decides about where the attention is going and how the vehicle is going to maneuver itself. It's not only Tesla who built that kind of a system. Wave does exactly the same thing, and that's why I had Wave on the slides. Wave was founded in 2017, and they were the only company at the time who believed that transformer is the right architecture for the future of AI, for physical AI. So now we're building up the architecture. I renamed it to Autonomous Physical AI System because it applies for vehicles, but also for robots, for robotic arms, for humanoids, anything you name it, even for multiple fleet of robots. So now we know that we have this data collection pipeline that is coming into the vehicle. We have the foundational model, the end-to-end model, but we also have the perception network that are somehow embedded in the end-to-end network. And the perception networks, like you might remember, these are those that are supposed to be responsible for self-awareness in that psychological EI framework. So perception gives you the awareness. Perception gives the vehicle the awareness. What's next? Well, because there is so many safety requirements and constraints, and we as humans are really very sensitive to everything safety and security, we would like those type of solutions to be grounded in some kind of a safety framework. For automotive, it is ISO 26262 certification, safety of intended functionality certification, also from ISO. In the United States, we also have NHTSA, which is National Highway Standardization Agency, and multiple state laws. In Europe, we have European Union laws and whatnot. Every country has some kind of set of laws in addition. So how do we make sure that we actually prove that the systems that we build is validated, sufficiently validated to fulfill the safety framework? To do that, we also use generative AI. So basically, we put the entire system into a simulation, and you can see now the next maneuver does not go on the vehicle yet, so it does not go to that inference compute that Jensen handed over to Wave, but it basically goes back to school. And that school is the simulation in the cloud. And frankly, to wrap it up in the simplest terms, is the world model in a simulation that is going to generate new type of behavior for the vehicle to, one, train itself, teach itself how to behave in that new environment, and also to make better decisions, to improve the accuracy, to improve the latency, and to improve the reasoning at the end of the day. So that's how it works. And then after multiple iterations and multiple scenarios defined by the safety standards, when the vehicle is ready to be deployed, it goes into the deployment. How does this simulation look like? I took a snapshot from NVIDIA from my times, from 2022. They have a newer one, but I'm going to run this one. So basically, you go and collect data, and then based on this collected data, you render the scene in a simulation that is one-on-one representation, rendering representation. And on top of that, you can create new type of digital assets in your simulation framework, and you can put snow on top of the scenario that you created. And if you build your simulation such that it's going to be physically verifiable, then you can basically drive your vehicle in this new type of generative world model behavior. So for example, the boy and the ball. That's how it works. This is, of course, a simplification, because you're going to have an entire evaluation engine for all possible key performance metrics for any set of driving behavior that you can imagine. So it's going to be split into driving functions or features or skills of a robot that are supposed to be evaluated. To give you an example, when a vehicle goes straight, it basically has to keep the lane. So that's the KPI, keep in the lane with certain distance from the lane. But the moment the vehicle goes and changes the lane, changing the lane has a set of new KPIs. For example, the distance to the vehicle. Ahead of me, the distance of to the vehicle. Behind me, the smoothness of that change, the velocity of that change, adjusting the velocity in case something happens between you or on the sides. Each and every one is measured on the go, or real time, all the time. So I reassure you that companies who are building serious autonomous machines, they are assessing those KPIs with at least thousands of different evaluators. Okay, so now we are building up our architecture, and what we added is the simulation world model that we just discussed. And in addition, I put mixture of experts. Why mixture of experts? Well, one, in the past 2 years, the AI community came up with that concept of mixture of experts to keep improving the domain-specific training of either autonomy or really just intelligence. A mixture of experts is known in the enterprise. In fact, enterprise LLMs or agents based on LLMs are using about 250 experts in their solutions. So it's a lot. I think in autonomous driving, it's still much less. But the reason they're important is because when Tesla is scaling the robotaxi from Austin, Texas to, say, California Bay Area, they are deploying new type of experts that are taking care of the regional differences between Austin and California. So that's one that is important. And then the next one is going to be, okay, once you're driving or the robotaxi is driving you from Austin to California between states, how do the experts know where is the boundary of the state? So that's going to be next one to solve. I don't think we have a solution for that one yet. Okay, so now we talked a lot about what is in the vehicle and how does it happen that that vehicle is driving itself. There is a lot in terms of AI infrastructure behind the scenes. And that's the reason why NVIDIA is at the position where it is. NVIDIA is building this AI infrastructure not just for vehicles, but for any intelligence you can imagine. Intelligence for healthcare, for biotechnology, for medicine, for LLMs, for agents, for digital AI, for physical AI. You name it the way you want to name it, depending on where you work. And that infrastructure requires 3 computers. One is for training, so that's the training compute here. Second is for simulation, for digital twin. And the more we talk about physical world, the more we're going to talk about digital twins. That simulation is going to stay with us for as long as we shall live. It's not very straightforward for the AI community who works on the digital AI, but for physical world, you're going to need the digital twin. If anything, just for the safety purposes, but really not just that. You really want your AI to be synthetically trained in the simulation world. That's much better, much faster, much more cost optimized. It is just that we have not seen the inflection point yet when the digital twin is being created through the use of Gen AI at scale. There are approaches, but they're still solving various problems with nerves, with 3D, GUT, and various different techniques. So it's coming. I don't know when it's coming. Maybe in a year, maybe in 3 years, maybe in 5 years. I'm not going to quantify. And that inference compute that we discussed, that's the chip that Jensen was giving to Wave. Altogether, it's called AI Factory. Why? Or why even that term? The AI Factory is actually a very, very important term for physical AI. Just the same as for the LLMs or agents in digital AI, but maybe it's much more straightforward when you talk about physical AI because of that feedback loop. The feedback loop of the data that is coming from the vehicles, they come non-stop. Like every time you drive your Tesla, it collects this data, whether you want or not. With a snapshot of 30 seconds, it is catching the events that are meaningful for Tesla network to improve. And you have various techniques like shadow mode that is going to catch when the improvement is required and when the driver does not agree with the decision of the vehicle. But basically, this data pipeline is making sure that the feedback loop is alive. And that feedback loop lives on. It basically lives on in the AI factory non-stop. We don't even know about it. We don't really think about it, but it's a living organism with its own nervous system. And that one is also going to live for as long as we shall live, or maybe even longer than us. That's how we create physical AI. That's why physical AI really, in general, AI is kind of infinite, like it grows, it keeps growing. Of course, NVIDIA is the first who is going to tell you about AI Factory because it's their job, like basically it's their business. If you want to know practically what it looks like, you know, from that green slide here on training, simulation, inference, you can see that DGX Cloud Compute is basically all those GPUs that go into data centers in the big rack. They are these days connected through the NVIDIA NVLink, which makes sure that the bandwidth is extremely large and the speed of communication is also growing. And then you have the simulation compute and you have the inference compute that we discussed. So if this is the case, then what are the results so far? What we know is that about 50% of Tesla users are using full self-driving features on their premium vehicles, only on premium. So premium means Model S and Model X. It is not Model 3 and Model Y. So I don't know how they count it, that's just the number I got. I think it's way less. I actually think that people are not aware about full self-driving because one, people are hesitant. Two, there is a lot of controversy around the CEO. And three, it's really working really well in California and now in Texas, but that's about it. So what do we know? What is interesting, an interesting trend is that NVIDIA was able to ramp up the simulation, so the digital twin, to 6 million users over the course of 2 years. 6 million is a lot of people in 2 years. So to me, it's growing super fast. Just to give you a comparison, the RoboFlow open source project that is basically taking the data set from the developers and enabling them to use computer vision neural networks has about 1 million users. And it's been going for at least a decade, completely open source. So just what I'm saying is that the number is staggering. Another number that is staggering is the valuation of Figure AI, so the humanoid company from Palo Alto, or maybe San Jose now, who got a 39 billion valuation of the company for 1 billion investment within 2.5 years. They were founded 2.5 years ago. So to me, I've never seen anything like that, maybe except OpenAI. And another one, well, if we are talking about so much compute, and the compute is actually, the demand for the compute seems to be infinite, then we need energy. And so, of course, all the countries all over the world are thinking about energy, and NVIDIA is doing everything they can to accelerate the energy supercomputers. So what is next? Well, so it seems like we are somewhat in the middle with this physical AI. It's going, but it's not here yet. What's next is that we're going to see the video word models that are going to keep improving. And one example is Fei Li, which she is also called the godmother of AI. She wrote that book, The Words I See, because she created ImageNet, and that's how she became popular in this community. So now she has this company, Word Labs, where she's basically claiming, let's create the word models of anything. Spatial word models of anything. And you saw some kind of like animations, but also real world. And so that Spark library that you just saw, it's open source and it's available to be used on the web. It's very interesting for developers because it democratizes access to generative word models. It's all open source and it's basically available for you. So that's one. Of course, nobody else but Google came up with Genie 3 earlier this year. And they also have these generative word models. They call it Frontier for word models, where you can basically prompt any type of word model you want, and it's going to generate this video for you. And if you're lucky, it's going to be an interactive video because you can embed it on a simulation platform that in turn has an engine that is embedded in physics. And so you can use it for at least synthetically generating the data set for your physical AI. So what I'm saying with this is that basically it's at the tip of your fingers. All those tools are around. We just don't see how they come together if we are not in the field. But physical AI is really a field for software engineers. I'm going to skip for the sake of the time, and we go to humanoids. So we have, as I mentioned, Figure AI that has those commercials where humanoids are able to do your laundry, so basically to fold your laundry. How real is this? So this is an interview with Time, and they're basically discussing that, well, it's not quite as real as it looks in the demo because we trained for the demo and, we basically recorded the video of the demo in that instance where everything worked, like it's a demo. But I tell you, from the perspective of autonomous vehicles, if we take end-to-end neural networks as a first principle that works, then humanoid AI is just around the corner. In fact, humanoid AI software is going to come much sooner than the body of the humanoids. And the reason for this is because we're going to deploy the digital twins to teach humanoids how to perform various skills, various tasks. Building the hardware is a little bit more difficult because the supply chain for humanoids does not exist. So we first have to build the supply chain and then scale it, and then it has to be cost effective, so the economy does not work as easily. But the economy of AI, if you are well capitalized like Figure AI, may actually work well. So that's this one. And one more thing, the specialized compute that is coming next year and has been announced by nobody else but NVIDIA again. Ian Buck was just talking about it in June, maybe, in San Jose, where he announced the Vera Rubin CPX, which is nothing else than a gigantic GPU with a gigantic context. Basically, this is a new type of architecture that allows you to handle 1 million token context. So that big of a context. And it's really useful for one, code generation. So basically, if you have a big repository for some kind of like enterprise solution, you can put all this repository as a context. And then the distribution, the architecture allows you to distribute the processing of the context differently than the generation of the new code that you are prompting for. And because of that, there is no latency or less latency, and frankly, the generation works more smoothly because the context is being processed separately. So it matters for coding, even more so it matters for physical AI because of the video processing. If you are able to put 1 hour of video processing into one context, then your generation on the inference compute is going to be much smarter about how to reason about your next maneuver or next movement of your robot. So all those three technologies are basically converging. The generative world models, the robotics in general, and the compute for that. And all this, big people are talking to each other frequently on a weekly basis. So they inform each other about the requirements that they have in order for, say, self-driving to advance, or coding to advance, or maybe even video generation to advance. So let's talk about cost. The cost is a really interesting thing with AI, because you would think that the lowest cost per energy unit, so the lowest cost per watt, is going to generate the highest return of investment for the customer. That's actually a reasonable thing to say, and it's true. But there is a caveat to that. The token generation rate per unit energy is your AI factory revenue. So it's not only the return of investment, it's also the revenue from the AI factory that, remember, is going non-stop live with that feedback loop. So the moment you start deploying AI factory and it keeps going, you really, really want to reduce your energy and reduce your cost of compute per energy unit, because otherwise you're going to be out of business very soon. And when you are architecting your AI data factory, that should be your #1 criterion, how you're going to build it. Lower the cost. Make sure you build the architecture at a scale that will provide a better and better architecture for as long as you shall live, for every next generation of the GPU or whatever semiconductor you're going to pick. That's really #1 criterion. And it proves to be true with NVIDIA as of today. The previous generation, which was Hopper generation, was compared to Blackwell generation, and Jensen delivered this keynote at GTC Washington, DC just 2 weeks ago, where he got the analysis from SemiAnalysis, an independent company, and they basically said, yeah, frankly, the cost from Hopper was 10 times higher in comparison to Blackwell. So it's that much more incentivizing to use the new generation. And that's why sometimes in the earnings call, you're going to hear him saying that, yeah, well, if you bought Hopper, you may need to replace it with Blackwell, because it's going to be much less expensive to use Blackwell for the next years for you. And then after Blackwell, there is Rubin. And, Rubin comes with CPX. And after Rubin, there is the next one. I forgot the name. So remember that. And so this is now the speculative part of the talk. Because if this is all true, and if you assume that everything is going to go great, and everything I said is right, and physical AI is just going to keep growing the way I'm saying, then what is the impact of physical AI on the GDP, on the economy, but also on those, first psychology values that we discussed at the beginning, the human agency, enabled of human agency, the systems resilience, the improvement of system resilience, and the pace and rate of system resilience, and collaboration opportunities for humans, for machines, for humans and machines. How do we even quantify it? So I just did this exercise with myself for 2030 target, and I give you a little bit staggering numbers, because I only analyzed the US because that's where I live economically, so that makes sense to me. So the US GDP is about 30 trillion with a T dollars for 2025 per IMF estimate. 5 years ago, it was about 10 trillion less. The previous 5 years ago, it was about 5 million less. So if this is the case, we have 5 increment, then we have 10 increment, then maybe now we're going to have something like 20 increment instead of just 10 in the next 5 years. And that's why I came up with this 50 trillion. Is it true or not? I don't know, because, in general, many say that economy is in recession and there is a rolling recession and not every field is affected by the AI. In fact, there are multiple that are not affected at all or even affected in the negative manner. So I'm not sure if, the lay woman like me can even talk about economy. It's just my wishful thinking about how the GDP can grow. And same with economy, with the percentage of economy. At the moment, it's something like 2.9% annually. I don't know, is it going to double? I don't know, it's just my guess. Even more interesting is the human agency. Do we really enable humans with all this technology that surrounds us? And really here, the responsibility is on us. Basically, all the developers and the leaders who are going to guide the development projects, because it's up to us how we design it, and it's up to us how well aware we are of this AI component in the solutions that we are building. It's not that it's going to build itself with AI. It's not. And we know that from autonomous driving, the previous generations of the solutions that we didn't discuss in this talk, they were basically more kind of like rule-based, and they were more modular, and they were just not necessarily enabling the motivation and intent of humans. The way we train the Tesla neural networks or the wave neural networks is more with the motivation and intent that comes from the data, because the vehicle learns about the human behavior, and human behavior is you and I driving. So we basically teach the network how we want to drive and how we expect that the vehicle should drive us. That wasn't the case in the past. Yeah, so the resilience, remember the first call from the White House? I don't know about the resilience. It's another counterintuitive topic, because the way we built was very much a patchwork, the way we build the technology for many different things, for manufacturing, for factories. To give an example, legacy OEM, the car manufacturer, would have something like 70% of automation in the factory. Whereas the new type of a car manufacturing, like for example, let's say in China, they automate to 96% or more. So you can control the resilience much more if you automated everything, because everything is software defined. So you are actually in charge of that software. Then you can also be in charge of the resilience. If half of the things is not automated and not software defined, then you actually don't know. And of course, software has its own problems to be controllable. Collaboration, again, it's all up to us. How well do we want to collaborate? And in Scandinavia, people are very community-driven. Believe me, there are parts of the world where people are not. In fact, the individualism is rewarded so much more than community work. And it's really our responsibility to make sure that the systems we are building are not individualized. They're not driven by the individual need, even though we can still profile and domain specify it for an individual. But the greater good of the community is way more important in the solutions. Well, that was a little bit about my psychology of life. Now the timeline. So I had this timeline changed so many times this week. I've been changing those slides this week just because of this freaking slide. So remember, we had ChatGPT moment 2022, the AV moment. To me, it's already here. To some other people, it's not. I don't know where to put it, so I put it somewhere before 2030. But I actually had a much more straight line for both digital AI and physical AI, with the inflection point of physical AI a little bit later, but they would cross at some point. But after talking to some people from Scandinavia, I realized maybe humans are not ready for this type of exponentials. So I now made them here as if we were not yet at this inflection point. And then I watched this interview this morning where all the AI people, like Fei-Fei Li, Jeff Hinton, Jan LeCun, Bill Daly from NVIDIA, Jensen Huang from NVIDIA, and Joshua, were rewarded with Queen Elizabeth Prize, just like yesterday or the day before. And they were in a panel and they were discussing, and Jensen said something brilliant as always. Well, that's not the right question to ask. We are already in it. It's already happening. It does not matter when and which inflection point, and he didn't say it with those words, but basically I told it myself. Well, it really does not matter. What matters is what we do about this entire AI revolution today and how we're going to proceed to become better. So if there is anything you should take away from this talk, is that the future is simultaneously defined by software. So we are hearing about software-defined vehicles in that industry, but we really deal with software-defined machines all over, everywhere. And it's all driven by AI, especially those end-to-end neural network prove to be exceptional if you have enough data set and enough compute to capitalize on them. And then they will be present all over, in digital, in physical, you name it. We are not necessarily exposed to physical AI that much, but it doesn't mean it's not happening. And now I have to ask about the time check. How much more time do we have? We're done? 2 more minutes. Okay, I had one more thing, but I'm just going to skip it. I vibe coded an example for you. Which was about disaster response from the past. So I'm just going to tell you that in 2014, like Lisette said, that I was working at the White House on this project about smart America. So basically the glimpse of the future for America. And there we had humanoids and autonomous vehicles and drones, and they were all supposed to work together in order to solve the emergency crisis, like firefighting or earthquakes, or maybe even you know, the war diagnosis today is a topic. So we showed this and we built that entire system. I'm not going to show the system here, and I'm not going to show the vibe code, but you can watch it later whenever you want. The slides are available for you. Thank you very much. And you can ask me a question, send me an email. I will respond to every single email. Thank you.